The beginning of 2.6 covered all the different kinds of rational functions, how to graph them. I say that the two most important slides from the beginning of 2.6 are this one, which is the vertical and horizontal asymptotes. I think yours looks different up here, like I gave you an actual example there. But you want to make sure you know how to identify the vertical asymptotes, which is where your denominator equals 0, and then the horizontal asymptotes, which occur one of these three ways. If the highest exponent in the top is less than the one in the bottom, then there's a horizontal asymptote at y equals 0. If they're equal, then it's y equals leading coefficient of the top over leading coefficient in the bottom. And then if it's greater than, then there's no horizontal asymptote. So this needs to be ingrained in your brain, okay? You need to know everything on this slide. This slide kind of put it all together. So this is what you would do to graph them. You would determine, and I would say that I would go horizontal and vertical asymptotes first. So I'd probably go to the step 4 first, do the vertical asymptotes. 5, do the horizontal asymptotes. Then do my intercepts, look for symmetry, and then plot the points in between. I'll kind of go in that order. You will have 2 questions on your test from this section. They count 24 points each. So technically it's half your test, which these two sections are half of the 4 sections that you know. So it has equal weight, okay? So the other 40, so this makes up 48 points of your test. The other 52 points come from sections 4 and 5. But they'll be broken down. So like I'll give you 2 different functions. For each one, you're going to tell me the vertical asymptotes, the horizontal asymptotes, if there's a slant, which we're going to talk about today, what the intercepts are, what the domain of the function is, and then graphing the function. So it's broken down into parts, but the overall question is like 24 points if you add them all up. Okay. All right, so I'll let you work on number 1 if you didn't start it already of the warm-up. Find the vertical, the horizontal asymptotes, and then graph it. Use your intercepts, use whatever information you need in order to graph it. And then you can hold off on 2. We'll do that later. All right, so I'm going to go in order of like what it asks. The first thing is the vertical asymptote. So I would take my denominator and set it equal to 0. I'm going to get x squared equals 16, and x would equal plus and minus 4. So my 2 vertical asymptotes occur at x equals 4 and x equals negative 4. Do you think the x equals part of those is important? Yeah. Why? What if I just put 4 and negative 4? That's not a line, right? They have to be lines. So I know I keep trying to like force it on you, and some of you keep losing points for silly stuff like that. Okay, make sure that when you give an asymptote, it's a line, which means it's a y, an x equals or a y equals. All right, then we would do the horizontal asymptote. So I would look at the leading, or the degree in the numerator over the degree in the denominator. Or not over, but compare them. What's the degree in the numerator? 2, and in the denominator? 2. So because these are the same, we do y equals the leading coefficient of the numerator over the leading coefficient of the denominator. What's the leading coefficient in the numerator? 4. The leading coefficient in the denominator? 1. So I get y equals 4 over 1, or y equals 4. And again, the y equals is important there. With me so far?
So you said just putting x equals plus or minus 4 is wrong?
You just have to have the x equals. You can't not have the x equals. So x equals plus and minus 4 is fine. Just when you graph it, make sure you have both. Yeah, but you can't lose the x equals part of it. What was your question? Well, I'll go back to it. Yeah. Okay, so now start doing your points, and the first ones come by way of your intercepts. So for the x-intercept, or for the y-intercept, I'll plug 0 in for x. I get 4 times 0 squared minus 16, which is 0 over negative 16, or 0. So I've got 1 intercept, and I know it's also going to be one of my x-intercepts, okay, but I want to check to make sure there's not another one. So for my x-intercept, for my y-intercept, I said it for the first time. X-intercept, I'm going to plug 0 in for y. So 0 equals 4x squared over x squared minus 16. First step in every single one of these rational functions is going to be multiplying by that denominator. So I can skip that step and just set my numerator equal to 0 when I'm solving for my x-intercept. So I'd get 0 equals 4x squared. X squared would equal 0, and x just equals the square root of 0. But there's something important about that step. What should you identify when I go to square root that? The multiplicities too. Good. What's that tell you about that point? It's going to bounce. Okay, so now I've got my x-intercept, my y-intercept at 0, 0. And I know it's going to bounce off that point. Everybody with me so far? Okay, so I'm going to plot what I already have. So my vertical asymptotes at -4 and +4. And my horizontal asymptote at +4. And then my x and y intercept at 0, 0. So what I don't know yet is if this bounces but opens up or bounces and points down. And it can cross through the horizontal asymptote. Sometimes they cross through in the middle there. It can't cross through vertical, but it can cross through horizontal, okay? But what other pieces of information can you gather from your equation that help you eliminate some points here? What's the first thing on that 7-step before you even start plugging in points? Symmetry. So what do I know about the symmetry of this function? What happens if I plug in a -x? It goes back positive. So what does that tell you? Symmetric to the y, okay? Which means whatever happens on the left side of my graph happens on the right side of my graph, okay? So I can literally just plug in 2 points and be done. I would plug in a point that is either on this side or this side, and then it would reflect on the other side. And then plug in a point either on this side or this side and reflect over the y-axis. If you're not great at symmetry, then you're going to be plugging in some extra points, right? Because you're not sure what's happening on those sides. So I'm going to start by plugging a point to the left of my furthest left asymptote. So let's say I plug in -5. I would get y equals 4 -5 squared over -5 squared minus 1. 4 times 25 over 25 minus 1, 100. 16, thank you. My graph thing is cut off because I zoomed in too far. Okay, 4 times 25 over 25 minus 16. And I get 100 over 9, which is 11 1/9, which is definitely above my asymptote. So I can go to -5, and 11 1/9 is like somewhere up here. It doesn't have to be exact. And then I know my curve is staying above my horizontal asymptote, which looks like that. Because I know it's symmetric, I know this happens on this side. If you didn't, then you would plug in a point like 5. And I would see that it would also be 11 1/9, and I would plot it above that point, above the horizontal asymptote, and follow your curve. Still with me? Okay, now I got to figure out what's happening in between those two vertical asymptotes. Katie?
When you do the L looking thing, where's the curve supposed to be?
So you want it to be as close to those asymptotes as you can without them hitting. And then the question, that's why we plot points, is it going above the horizontal asymptote or is it going below it? So all you need is 1 point to confirm that.
So the point, the line hits one of the points?
Yep. So it hits, technically it would be -5 and 11 1/9 there. I know that's above my x-axis, so I know it goes along the vertical asymptote and then turns and goes along the horizontal, but it stays above the horizontal.
Okay.
If I had gotten something like 2, let's just say when I plugged it in, then I would know it would be underneath like that. So what that 1 point tells you, is it above or below that horizontal asymptote? You're welcome. Okay, so now I'm going to plug in a point from that middle range. So let's say I plug in +1. Make it easy on myself. Y equals 4 times 1 squared over 1 squared minus 16. And I get 4 over -15. So +1 and -4/15. And again, I know it bounces and I know it's symmetric, which means the same thing's going to happen on this side. And so my curve does that.
Do you have that plot of points?
So sometimes it can point up. You've just got to confirm which way it's going to go. It never goes all of them up, but it can go cubic function shaped in the middle, or it can go the two L shapes down and the parabola up. So I would just say the more secure you can be about your graph, the better off you're going to be. These are the last 2 questions on your test. So if you got the extra time, I would say plug them in.
Wait, can you go over how you did that again? How you got the...
So you saw me get the 1, right? Like when I plugged in 1, I got -5, right?
15, yeah.
So that's this point here. And then I know 2 pieces of information about this graph. 1, it's symmetric, so that brought me this point. 2, it bounces off the 0, which is consistent with that curve.
Okay.
You're welcome, Sophia.
Do you have to find like the L's?
You mean to know if it's above or below?
No, I'm saying like why can't you just like graph the parabola? You have to find
The graph is, yeah. So you, for every range in which you're introducing the asymptote, so if I have 1 vertical asymptote, I need to plug in a point to the right of that vertical asymptote or have an intercept on the right and on the left.
Okay.
If I have 2 vertical asymptotes, I need 1 to the left, 1 in the middle, and 1 on the right.
Okay.
And then hopefully there's enough of a pattern to establish to know what they look like. Okay? Common ones like this, like if you have 2 vertical asymptotes, are either like this, where you've got both of them up and 1 parabola pointing down, or the flip of this, where both of them are down and the parabola points up. Or you can also get ones that have like 2 vertical asymptotes and a horizontal asymptote, and then alternate corners with a cubic function shape in the middle, which you'll see an example of that later. Okay, so they're not always parabolas in the middle. They're not always, but this would not be symmetric. Like you would know that that's not symmetric to the y-axis. Does that make sense?
Yeah.
Yeah, okay. All right, so let's finish with the slant asymptote. I'm going to go back to the notes, and this is where we left off. So a slant asymptote occurs if the degree of the numerator is 1 more than the degree of the denominator. So if the highest exponent in the numerator is 1 more than the denominator. It could be 3 and 2. It could be 10 and 9. Okay? The relationship just has to be 1 more. And then you find it by dividing the numerator by the denominator and ignoring the remainder and just keeping the quotient. So we'll do like both. You can do long division or synthetic division sometimes. It's going to be your choice. But then there's other times where you're going to be forced to do long division. So we'll walk through the review of both of those. And you totally ignore the remainder. You take what the quotient is and set it equal to y. And that's going to be your slant asymptote. So think about what happens if I have something like an x to the 4th plus blah, 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 over x to the 3rd. What's my quotient going to look like when I divide the x to the 4th by the x to the 3rd?
1.
X to the 1st always, right? What if it was x to the 8th and x to the 7th? Still x to the 1st. So what kind of graph is an x to the 1st? Line. Good. So if you for some like way are doing your slant asymptote and you end up with a parabola, you did something wrong. Okay? These are going to be linear because if it's slant, it means the one at the top is 1 more than the one in the bottom. Okay? So your asymptote should always be a line, and it will have some sort of a slant to it. That's how it's called, the slant asymptote. Okay? You can have a vertical and a slant. You can have just a slant, but you cannot have a slant and a horizontal one. Okay? Think about the rules for horizontal. What is it if there's an exponent that is bigger in the top than in the bottom?
No.
There is none. Okay? So you can't have a horizontal and a slant. Does that make sense? Because the one in the top, the degree in the top would be bigger than the one in the bottom, which would mean it has no horizontal asymptote. All right, so this just says find the slant asymptote. So we're not graphing it yet, we're just finding it. So we'll do it both long division and synthetic because we'll review both, okay? So if I was to do this long division, I would do x squared plus 6x plus 2 divided by x plus 0 because I don't have a constant. What do I have to multiply x by to get x squared? X. Multiply it by both. X squared plus 0x. Change your signs. This cancels. God bless you. 6x. Bring down the plus 2. What do I have to multiply x by to get to 6x plus 2? 6. Multiply it by both. Change your signs.
Understood.
Hi. So I totally ignore the remainder. I don't need it, okay? The slant asymptote comes from setting my quotient, which is the numerator, equal to y. So I have a slant asymptote at y equals 6 plus x. Or x plus 6, sorry. Which is a line that would start at the y-axis at 6 and then a slope of 1.
You don't look at the remainder?
Nope, you don't need the remainder. And this time I could have used synthetic, so I could have put a 0 on the outside. And then I would have listed all my coefficients, 1, 6, 2, bring down the 1, multiply it, put it in the next column, add it, multiply it, put it in the next column, add it, ignore the remainder. The 6 would be the constant, and the x would go on the 1, you're welcome. And I'd get y equals x plus 6. So either way, you get the same answer. I'm not going to graph this full out because it's got some ugly intercepts. You have to use the quadratic formula, but just to get a start on it, if you could think about what this would look like had I gone all the way through. Do I have a vertical asymptote?
No. 0?
X equals 0, right? That's a vertical asymptote. I set this bottom equal to 0 and I would get x equals 0. That's my vertical asymptote. My slant asymptote is x plus 6, so 1, 2, 3, 4, 5, 6. There's the y-intercept, and then slope is 1. So my slant asymptote would look like that. Vertical would go up here. Mauricio.
So normally, like, if you don't have, so like, I know you already said that you'll have, if you don't have a horizontal, you have a slant.
Not necessarily. You could have neither.
Okay.
Because if it was x to the third in the top, but x to the first in the bottom, it's
yeah.
neither, right? They have to be one apart. Does that make sense?
Yeah.
Okay. So from here, and again, I'm not going to keep going because you have to use the quadratic formula on the numerator because it's not factorable to get your intercepts. I would get no x-intercepts because if I said no, I would get no y-intercepts because I plug 0 in for x, it's undefined. Okay? Which tells me it's not going to cross the y-axis at all, which makes sense because that y-axis is an asymptote, okay? But when you have a slant and a vertical, your graph will either take the shape like this and this, where it's opposite corners, or it would be here and here. So for that, again, maybe this would have been factorable, and I would have taken that and factored it and gotten my x-intercepts. Those would have been points that would have helped me. Or I could have plugged in a point to the left of 0, like -1, and plugged in a point to the right of 0, like +1, and seen where those points were going to go. Does that make sense?
So you don't have to technically get the x-intercept as long as you plug in a point.
I mean, on the graph, I mean, on the test, it all goes together. The directions here just said find slant.
Okay.
So you would have been done. But had this said graph, I would have kept going.
But like, you don't have to find the x-intercept basically, but like.
It'll ask for it.
Oh, okay.
If it didn't ask for it, you could plug in any points you wanted. Right? Because this would have gotten ugly. You would have been approximating a square root because it's not factorable, right? But let's just say, here, I'll just keep going. Let's say I plug in 1, right? So I get 1 squared plus 6 times 1 plus 2 over 1, 1 plus 6 plus 2 over 1, which is 9. So 1, 9 tells me it is above this point, which means it's going to be that curve. And if that's the case, it's going to be this curve. If I had plugged in a -1, I would have gotten 1 minus 6 plus 2 over -1. And I would have gotten -5. Oh, this one is a special case one. I shouldn't have done this. Okay. It looks kind of funky when you graph it. But you can get the idea. Okay. It would have been 3. It would have been underneath that curve. And those points, if I had found my x-intercepts, would have been somewhere on there. Does that make sense? Yeah. What's the domain of this function? Since I didn't go over it the last time. What's the domain of this function? X cannot equal 0. So in interval notation, it's -infinity to 0, union 0 to positive infinity. Your domain should mirror your your vertical asymptotes, right? So it's the opposite. The vertical asymptote is where it would equal, and the domain is where it wouldn't. Does that make sense? Yeah? Okay. This one. All right, this time again, you can't use synthetic because that squared is in the bottom. I would have divided x to the third plus 0x squared plus 0x minus 1, because you're missing those terms, by x squared plus 2x plus 2, and your slant should have been y equals x minus 2. Everybody good so far? Yeah? Okay, so this just puts it all together. Find the horizontal, vertical, slant, and if there's any holes, and then graph the function. I'm going to add on here to add domain. Or find the domain. And the x and y intercepts. That'll help you graph. So if this was, this would be a good review for your test, a question like this, where you're finding all of those individual parts based on one function. All right, so first thing I did was factor the numerator and the denominator to see if this is going to simplify and give me any holes. Do either of the expressions in the top cancel with either in the bottom? No. Okay, so I already know there's no holes. Now I can go straight to I would go vertical asymptote first just because I think it's easier. Set the denominator equal to 0. And I get my vertical asymptotes are x equals -2 and x equals +2. Everybody good so far? Yep. Okay, horizontal asymptotes. So what's the numerator, degree of the numerator? 2. And the denominator?
2.
Same, which means the leading coefficients, right? So y would equal the leading coefficient in the top, which is 1, over leading coefficient in the bottom, which is also 1. Is there slant asymptote? No, so no slant. So the exponent in the top has to be 1 more than the one in the bottom. And you can't have horizontal and slant.
Maybe y equals 0, which means no.
Not y equals 0. There is none. Because both the exponents in the top are the same. The one in the top is going to be 1 more than the one in the bottom. Okay, so now let's do the intercepts. Okay, do the y-intercept. So I'm going to plug 0 in for x. I get y equals 0 squared minus 5 times 0 plus 4 over 0 squared minus 4. This cancels, 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 and I end up with 4 over -4, which is -1. So my y-intercept is 0, -1. Everybody still with me? Okay, x-intercept, to set the numerator equal to 0. And I already factored it. So if either of those are 0, the expression is 0. So I have 2 x-intercepts. One at 4, 0, and one at 1, 0. Good so far? Yep. Okay, now let's start graphing that stuff. Is there symmetry on here? Like, is this symmetric to the y-axis? No. If I plug in a -x, it's going to cancel from the squared term, but not the 5x. So it's not symmetric to the y-axis, which won't help me. And then not all the signs are going to change, which would be the origin. That won't work either. So I'm going to start with my vertical asymptotes at 2 and -2. My horizontal asymptote at y equals 1. My x-intercepts at 4 and 1. And my y-intercept at 0, -1. So this is where I'm at so far. Okay, so I definitely need more information. Odds are, with the shape in the middle, okay, it's either going to be a parabola but that both point up, or one of those cubic function shapes. I know it's probably not going to be a parabola because then it would be symmetric to the y-axis. Okay, so my gut instinct says it's a cubic shape in the inside, and then it's going to be down right corner, top left corner, because those are usually opposite when it's not symmetric. But I don't know for sure, so I'm going to plug in some points.
Oh yeah, how do you know it's cubic? By the plug?
Cubic is usually if it's not symmetric. Yeah, so when you don't know, then plug in your points. Yeah, so I'm going to plug something into the left of my furthest left asymptote. So I'm going to plug in -3, let's say. So -3 squared plus -5 times -3 plus 4 over -3 squared minus 4, and I get 9 plus 15 plus 4 over 9 minus 4. This is 24, 20, 8 over 5. So this is 5 3/5. So it's like here. So I know that this curve is now here. I already have a point down here, which tells me this curve is down here. Now the only other thing I need to figure out is what's happening in between the -2 and the +2. So I'm going to plug in -1. So -1 squared minus 5 times -1 plus 4 over -1 squared minus 4. 1 plus 5 plus 4 over 1 minus 4. 10 over -3, which is -3 1/3. And now I know it takes that cubic shape.
But you go through the horizontal asymptote.
So the middle one, if you have two vertical asymptotes, you can sometimes see it where it crosses through the middle. It cannot cross through a vertical asymptote, but it can cross through the horizontal. Those horizontals are really just impacting the outer two curves. Sophia?
So the intercepts count as like additional points?
Yep.
So for the right side, you might want to find
Exactly. If the intercept already gives you a point from that range and that's good for you, then that's good for me. You just have to have one from each section or look for symmetry. If you can figure out symmetry, it's going to help you too. Dominic?
Wait, you said it's allowed to cross the horizontal asymptote?
Correct.
Why?
Because technically that horizontal asymptote is affecting just the outer two bands, not the inside. It will never cross the vertical because that would make it undefined. So it literally can't have a point there.
It will never cross vertical?
Any of the, yeah, it'll never cross a vertical because that point would be
yeah.
undefined on your graph. But a 0 in the top works. It just is not, it's not undefined.
Could you have a hole in your vertical asymptote?
Yeah.
Whoa,
How do you do that?
that's crazy.
Technically it would probably simplify so you don't have the vertical asymptote, but that's where the hole would be. So it would kind of like cancel out your vertical asymptote.
It just wouldn't be one.
If in the beginning when we factored, if you could cancel something from the top and the bottom, like let's say they both had x minus 1. They cancel. Now your function is reduced, but you also have to remember that there's a hole at that spot. Because your vertical asymptote went away by canceling through that. So your vertical asymptote becomes a hole. Does that make sense? Yeah.
So
Sorry.
in that case, would the hole be 1, right?
So the hole, yes, there would be a hole where x equals 1 if it was x minus 1 that you canceled out in the bottom. So what's the domain of this function?
X is not equal to
It can equal positive or -2. So what's that look like in interval notation? Good. Mikhail.
How'd you get the point on the y?
It was one of my on the y-axis. It was my y-intercept. So that work. I don't even know where it is anymore.